Now the recorder's on. Hi, this is Michael Waits and welcome back to India Game Changer. Today we are joined by Satyanarayanan Chakravarthy, a co-founder at ePlane.ai. Satya, for my convenience. Thank you very much for coming on the show. How are you doing, by the way?
Thank you very much, Michael. Thanks very much for having me.
It is my pleasure. Look, you mentioned it before we started recording, so I have to ask the question. I told you beforehand, I'm just a curious guy. You said the first two syllables of every Indian name has a meaning. So your first two are Satya. What does it mean?
Truth.
Truth. I love it. So do you have brothers and sisters as well?
I have one sister, the elder one.
And what does her name mean, the first two syllables?
Interestingly, her name is very short and it has only two syllables. So her name is Rama, and I think it means beautiful.
Yeah, makes sense. Makes sense. Okay, I'm just curious. Anyway, thank you very much. And before we get into the central part of this conversation and dig deeper into ePlane, why don't we get a little bit of your background for some context as well?
So fundamentally, I'm an aerospace engineer. That's what I did for my bachelor's, master's, PhD, everything.
You care about planes. Go ahead.
Yeah, did my bachelor's at IIT Madras, went to Georgia Tech for my master's and PhD.
Wow.
Was a postdoc there a couple of years. Came back to teach here. Went through my career progression as a faculty member at this institution at IIT Madras, aerospace engineering. Built one of the world's largest combustion research centers in academia. While I was just getting ready to launch it, I decided that I need to actually go electric.
That is so interesting. Can I back up a little bit to Georgia? What was it? You said you went to Georgia Tech for your master's degree, yeah? What was it?
PhD.
And your PhD. What was it like living in Georgia for you? Like, where are you from originally in India, yeah?
I'm from Chennai. I was born and brought up in Chennai. I went to college in Chennai. I'm back in Chennai. So I've lived in primarily two cities in my life. Very boring life that way. Chennai and Atlanta. I probably spent cumulatively over 4 trips. About 6 months in Darmstadt, Germany. That's about it.
That's it though, right? What was it like living in Atlanta?
It was interesting. To give you a best example of what Atlanta is like for a lot of people in the US. So when I took my wife the first time, right? So we landed in Atlanta in the evening. So we drove directly to my apartment. The next day we were going doing groceries. She asked me the question, are we in America or South Africa? And that's because Atlanta actually has at least at that time I was in, they had like about a 65% African American population. So it was unlike a lot of other US cities. So it's very diverse that way, right? So
it is quite diverse,
you feel at home with most of that.
That's really interesting. My brother did his residency at Emory along with his wife as well. So I spent some time down there too.
Very good university. Yes.
Really kind of an unbelievable and a really dynamic city, as you mentioned. Yeah, it's very diverse, which is super cool.
Yeah.
And it's just an interesting view on the United States of America, to be fair. Yeah.
Yes, it is. That's the point I was saying. And of course, for me, the icing on the cake was I was around the time when the Olympics happened there, the Centennial Olympics.
Oh, wow. I can't even remember when that was. But yeah, that must have been awesome as well.
Yeah.
But you came back to India and came back to Chennai. Did you say you graduated from IIT?
Yeah, the same place that for a bachelor's, yes.
You did, right? And how do you get from teaching into founding?
The combustion center that I developed or set up is actually fairly large. It started with about $11 million funding, and it's now grown to about $30+ million in just doing research and engineering for a lot of industry people. So we've done like about 50+ projects. I'm always proud to say that we associate with GE Aviation a lot. For example, we've been doing a lot of work with them as a very good example. And the reason why we do this is because we actually do research at a scale that's very relevant to the industry, right? So that means like almost getting to the real conditions of pressure, temperature, all of that stuff for studying combustion in engines, right? So, which essentially meant that we have large, big engineering setups in our lab, and that essentially meant that we thought we could actually go develop big engineering products. So we have a rocket company, we have a micro gas turbine company, we have a waste to crude oil company, We have a Earth observation satellite company. We have a Hyperloop company. All of that stuff happening at the combustion center. And I thought to myself, if we could do all of those things with like co-founders half my age, why couldn't actually why couldn't I actually do a plane company myself?
Yeah, why can't you? There's nothing stopping you from doing it. So you're doing this while you're still involved in that combustion center. Is that true, or you're doing it
The
separately?
combustion center is still active,
Yeah,
but I think hopefully I have a fairly good administrative streak in me to have put it on a auto mode. So it's running by itself
I'm
while
sure
I'm
you do.
actually spending more and more time on my company.
So where does this interest for flying come from? Like, was your dad in the Air Force? Do you know what I mean? Or is it just something you've always cared about?
Oh no, I think Indians are actually kind of peculiar the way they grow up, right? So it's a highly competitive environment. So for me to actually get into my bachelor's at IIT Madras, I had to actually go through this insanely competitive exam,
I'm
and then
sure.
you get a rank, and the rank determines the rest of your career. It's kind of like a lottery,
Wow.
right? So I did aerospace engineering simply because I got that rank. I mean, you have a little bit of choice with
Right.
around the rank, but given everything, I just landed up in aerospace engineering, and then you're also familiar with the arranged marriage system in India, right?
I am.
So you start loving the wife that you get married to, and it's very similar in career too. So all of these things kind of go together. So when I started doing aerospace engineering, I quickly realized that aerospace engineering is not exactly about planes and rockets. It's about this mentality that you should be aspiring to do what other people think is impossible.
Tell me what that means, though. Like, that's super interesting, right? So it's not just about the planes. It's, you said, aspiring to do something that other people think are impossible. Is that just an IIT Madras thing? Like, where does that come from?
No, I think it's an aerospace engineering attitude around the world. It's actually an attitude. It's not a career.
Yeah, for sure, for sure. Go ahead.
Right? So, okay, go through the entire course in aerospace engineering. I know how a plane works. I still sit at the window and then look at the wing. And then when you start, the wing is actually right here. And
Right.
then when you're not taking off, the wing is actually up there. I don't know if you've noticed that. And then it's doing this.
Yep.
And you're like, oh my God, is it really going to fly?
Is that thing okay?
Right. So that's what actually is what aerospace engineering is all about, right? So how does it really work? And even if you knew how it works, it's so fascinating, right? So which essentially means that you go out and think about doing things that other people wouldn't even have thought about doing.
Yeah, so this is what I want to know, right? I think about a drone, and
Right.
I'm really curious about this. Is it just me? Because I have this philosophy, right, that everything's an overnight success 10 years later, and I use 10 as just kind of a random number, yeah, because it's
Sure.
far enough
Yeah.
away so that people are like, that's not overnight, but
Yeah.
close enough so that it feels like, okay, you've been working on it for a decade kind of thing.
Absolutely.
But drones, did they just come out of nowhere? Or is this something that people have been working on forever and that the motors got small enough, the blades got strong enough, the weight of the machine got light enough, and then it was just like, I think this is going to work? Because it looks like drones are now taking over the way we think about flight for
Yeah.
innovation. Do I have this wrong?
No. I think it's absolutely right, except that I have a different take about drones specifically,
Go ahead.
right? I don't really think drones are particularly aerospace. They are more like electronic gizmos or electromechanical gizmos.
Go ahead.
What you're trying to do is to essentially have a battery pack and then wire them up to motors. The motors are connected to propellers. So the motors turn, the propellers turn. So you start lifting up. The only thing that's going forward that's actually aerospace is what's called as flight mechanics. So something that actually stabilizes the drone from shaking around and stuff, right? And that's today actually shareware. That means you can
Yeah, that can be, anybody can
download.
do this.
Correct. So most college kids will actually take a shot at it. I think the key thing about drones is because there are like so many of these propellers that are running around, they start vibrating the whole thing,
Right.
right? To make a very rugged drone that you can actually sell like a commodity is a challenge when compared to what a college kid can actually achieve. So the real aerospace is in throwing in things like wings at it, wings, tail, the horizontal tail, the vertical tail, the flight, right? All of that stuff, which actually is where the challenge is, because these drones can actually last for about 10 to 20 minutes most of the time
Yeah, on
because
a
they're
battery,
always
it's
having to
nothing.
have these propellers
Yeah, yeah.
rotate. What we do, for example, in the e-plane company that we're supposed to be talking about,
We'll get
is
there.
right,
Go ahead.
is to actually put wings at these so that we can get what you call as drones itself, right? To be hovering around or going around for about 2 hours in the air and clock something like about 150 kilometers kind of distances. And that's what I think is aerospace.
I love this fact you're very particular about the aerospace part of this. No, I love it. And this is the truth. This is the point of the truth where you said you fell in love with the wife of aerospace that you were given. I can feel it. You know it. You know it for sure. But talk to me as a person who doesn't completely understand aeronautical engineering. By adding the wings right in the front and the back, or in the middle of the body and the back, and we can talk about exactly what E-plane is in a second, right?
Yeah.
Besides just pure stabilization, can you talk to me as well about how it changes the lift, the travel, the impact on the battery or the motor and all that other kind of stuff too? Because I'm super curious, yeah?
Easy. So actually, the stabilization that you mentioned comes next, right? So the primary purpose of a wing is to generate what we call as aerodynamic lift. And that's jargon. So pardon me for that, right? So what it essentially does is if you now have a wing and that's set in motion going forward, and you have the air or the wind going around the wing, there's sort of like a differential pressure over the wing that allows for the wing to be lifted. And when the wing gets lifted, its job is to actually try to balance the weight of the entire aircraft. All right. So what that means is that I don't need to have these vertical propellers that are, running around like what you see in the drones all the time. So I'm not guzzling any power, right? So where is the catch, right? Where am I actually having to spend the power on? While going forward, I'm clocking wind resistance that we call as aerodynamic drag.
Yep.
And all I have to do is to overcome the aerodynamic drag. And the aerodynamic drag is only about a tenth or even less than the weight of the aircraft that we need to balance with the lift, right? So that essentially means that I'm having to spend my battery on about a tenth of the power requirement when compared to if I were to be rotating these propellers all the time. In a drone, that essentially means that I can actually stay up in the air 10 times longer. And more importantly, I'm having to recharge my battery 10 times less often. And that means that I don't have to actually throw away my battery soon enough, right? And battery is actually the most expensive part of the plane. And I spend less and less, about 1/10 of what I have to do in a drone if I were to actually have a winged drone.
Is the battery also one of the heaviest parts of the plane?
It is indeed the most heaviest.
So this is really interesting because it feels to me like there are a bunch of wins here that are all very technical and technology related, right? In other words, battery technology is making progress, but tell me if I'm wrong here, but probably not as fast as like microchips are making progress, right? So you want to have that as small as possible, but you want it to stay charged as long as possible. So you're suggesting to me that in an E-plane, the way it's designed right now, the vertical lift that you get, right? You called it VTOL. Is that vertical takeoff and lift? Do I have that right? So with the vertical lift that you have,
landing.
and landing, excuse me. Yeah, sorry. But that vertical lift that you have at the beginning is is that the only use of the kind of drone propellers, or do they sometimes pop on when you're flying as well? Like how does that work?
That's the USP of the E-plane company.
How good am I, by the way? I just came up with that just now. Go ahead.
Absolutely. That's because you're actually thinking from first principles. You're not bogged down by dogma, right?
No,
so you didn't get taught about these things in a classroom by a teacher, right?
Nah.
That's the point, right? So the question we had to ask is, if I'm actually trying to marry a plane with a drone, right? We always think about getting what we want achieved. And this is also true in life, right? So with any people around, we always want to actually try to get to achieve what we want to get achieved, but we don't think about what else is happening, right? That may not exactly happen the way we want, right? So we're trying to marry two advantages of like a plane and a drone. The disadvantages will also get married. So and many people actually disregard that part, right? So what does it really mean? So when I'm actually trying to take off vertically with these propellers, the vertical propellers, right? Fine, you got the job done, right? But the wing is actually sitting like this, and the air is coming around like this. It's very slow, so it doesn't matter, but it's actually almost like in the face, if you will, right? It's a face palm.
Yep.
The wing, right? So the wing is
because you want the wing to go like this. This is where you get that.
The wing, so ideally, the wing should have been going like this, right? So there are people who actually try to do that and then try to flip this way and so on. Now, but let's say you just want to stick to a plane which will actually go up like this.
Right.
The wind is actually slapping on the wing, and that's not too good. Now, let's say I actually got to the point, and then you now move forward. The wing now kicks in and then produces the lift, but these vertical rotors now are actually a dead weight, right? And that causes a additional drag, and then they just weigh you down, and you have to carry them along all the way till you land, because when you want to land, you need them again.
Right.
Correct. So it's in aerospace, we have this dictum: takeoff is optional, landing is mandatory. Right? Right. So just because you want to land, you're actually carrying a bunch. So I used to come up with a very, very lame comparison. Imagine that people actually made buildings without staircases, right? And they expect you to carry a ladder with you everywhere, right?
Right.
And that's exactly what we're doing.
Got it. Go ahead.
Right. So question is, what do you do with these vertical rotors as you go forward? Is there a way we can actually utilize them?
Before you finish it, I want to know what you do, because the implication here is if you don't do anything about it, they're either dead weight, which means you're going to have to figure out a way to generate more energy and get the wings to go even harder because they have a weight on them. Right. So you're running into this aerodynamic lift problem. That's first of all. And second of all, you can run them, but then you're just running the energy anyway. So now you have battery problems. You're back to that thing.
Absolutely. Yeah? So it's going to guzzle power, right?
Yep.
So the question is there a balance, right? So the answer is yes. So one of the things that I did when I decided that I'll actually go electric, right, with planes, I didn't initially mean to immediately get into entrepreneurship, right, and co-found the company. I did what all professors would do, right? Start learning about this, and then look around what's happening, go to conferences,
right,
and present papers on some new research that I do on this, and also teach a course, right? So I think I'm the one who taught the first course on electric aircraft propulsion in the world in 2019. That's because a good professor, when he wants to learn something, he actually teaches it to unsuspecting students, right?
Tell me if I'm wrong here as well, but isn't the teaching part of the process of, do I really understand this kind of thing?
Absolutely, because if I had to make sense to myself, I need to be able to articulate this to a bunch of people. And if it doesn't make sense to them, it's not going to make sense to me.
Yeah.
Right. So the reason why we actually step out, stick out and then teach.
When you do that, right, are you also trying to learn even more? In other words, you're teaching a bunch of super smart students, right? Like they're, you know what I mean? Like you're in an aeronautics engineering class, right? Let's just be fair. These are smart guys and gals, yeah? And you're teaching this new thing to them, with electric propulsion. You're like, I think I got this. Do you ever have experiences, and I know this is a little bit of a tangent, where somebody in the class will raise their hand and say, yeah, but how about this? And you're like, oh, I've been trying to figure this out. Maybe that will help me, kind of thing?
Absolutely. That's exactly the reason why I would teach. So essentially two things happen, right? So particularly if I'm actually teaching a completely new course, right? It's new to me,
right,
but it's also new to the world, right?
Sure.
So you don't really have. So for example, we don't have textbooks on what I'm teaching. Right. I have to put together research papers, right?
It.
And then have classes on these papers, right?
Yeah.
And I've not written these papers myself, right? So I don't know exactly what's going on, right? So I just read them and then try to make sense out of them to the students. So if a student asks a question that I can't answer, the first response is I don't know.
Yeah.
Right. Right. But more often than not, I actually look for this situation that you talked about. So if I say I don't know and then the student actually figures it out, right, it's even better for me.
Sure.
Right. So that's now. Why did I bring this up? Because when we were going through this, we found that NASA has actually done quite a bit of work on. So NASA has done a lot of research on what's called as distributed electric propulsion. So what they did was to actually pick a plane which had a nose-mounted propeller and of course with a combustion engine. So they threw away the combustion engine. They removed the big propeller. Instead, they actually put a lot of small propellers that were powered by small electric motors and wire electricity to all these small motors from a battery pack. With this, what they did was to show that if you blow a lot of air with these small propellers over the wing can actually generate a lot more lift, right? But you need only so much lift as to balance the weight of the aircraft. So that means the wing can actually become smaller. And if the wing becomes smaller, a smaller wing can actually generate the lift that you want. And it doesn't actually experience the wind resistance as much as a larger wing. And you can save power there. So we try to do the same thing with the vertical rotors too now. So that's actually our USP and our IP. Right. So we figured out the positions where these vertical rotors should be, right? And at what sweet spot speeds that they need to operate, that will actually make the wing work much better so that I can make the wing very compact.
Right.
And by making the wing very compact and also fly very slowly, I can go short distances and also land in very tight spots. So this is what we think is actually required for a taxi-like operation.
What does slowly mean?
Slowly means that planes actually have to fly very fast because the wings will have to be effective. So for the faster you fly, the greater the pressure differential, across across the wing surface, because the wind speed on the top will be more than the wing speed at the bottom, and so on.
Okay.
Typically, these wings are designed for a particular speed that is usually on the higher side, right? So let's say, for example, if the speed were like about 300 to 350 kilometers per hour, by the time you take off, reach that speed, and then you decelerate back, right, you would have covered like about 50 kilometers, and that takes you outside a city. That's not a taxi that you would want to take for you want to go from one place to the other within the city.
No.
Right. So you want to have a helicopter kind of speed, right, which is essentially like what drones would do as well.
Yep.
Now, how do I do that trick? How do I actually get my plane to go very slow? Typical slow flying planes have very large wings because you need to have the large surface to compensate for that less differential pressure that you get, right? And that makes it less compact. I cannot land anywhere that I want in a crowded city.
Go ahead.
So this is actually very difficult to crack. And that's what we did because we are actually using the vertical rotors while in forward flight. The question that you asked first.
Yeah. How long did it take you to figure this out, and how much fun was it? Actually, is a better question.
The idea did not take too much time for me to figure out because I asked this question: if I'm marrying the advantages of two things, what's happening to the marriage of the disadvantages?
Yeah.
So that's a question that not many people really ask. Okay, so the moment I actually asked that question, I could actually figure out I need to do something about this. Right now, on the other hand, the other thing that I would like to actually also emphasize for tech entrepreneurs is your tech should actually be derived from business requirements rather than you say, I have this tech, I have to figure out how to actually make business out of it. That's not how entrepreneurship works.
Go ahead.
Right. So for me to actually have a taxi, I need to have a wing that will give me a long range, and I need to be able to fly slow so that I can do multiple short hops in a single charge, like how a taxi does.
Yeah.
I also need to have a very compact wing so that I can land and take off from tight spaces. This is exactly what I want for a taxi. And how do I do this in a VTOL? And that's where the question of how do I take advantage of not allowing the disadvantages to get mattered?
Right.
Yeah.
Yeah, or not even if they do get married, not to have them matter.
Yeah.
In a way that's cumulative or exponential.
Yeah.
How do you handle? Like, have you tested this? This is a flying machine. It's already tested. It lands and it flies and all this other stuff. Yeah.
So we have done a smaller version that sits on the table. That's what I said, goes up to about 150 kilometers, right? And stays up in the air for 2 hours.
Yep.
So we have tested it at that scale. We are actually assembling something that's about 3 meters wide. It's a subscale prototype of the actual taxi.
Yep.
Capable of carrying up to 50 kilograms of payload.
Okay.
And going about 100 kilometers. And that's something that we expect to fly by the end of next month. So this is all on the flights. But the concept actually has been tested in the laboratory with just a wing and a rotor. Right. So just to take these bare bones elements to figure out, like, am I getting extra lift because I'm positioning the rotor with respect to the wing at the right place and have the right speeds, right? We've also done like large number of numerical simulations.
What is the tech that needs to sit on the plane? Sorry, from a software perspective, right? Because I presume that these rotors are making constant micro adjustments to speed. Yeah. And also battery efficiency, trying to take as little energy as possible while running as fast as, all this optimization is taking place. What kind of software and tech is on the plane?
That's an interesting question. So this can actually be done at 2 levels. The constant micro adjustments that are required on these motors and the vertical propellers is primarily required during the vertical takeoff and vertical landing, or if I were to hover somewhere in the middle, right? While going forward, the adjustments are actually coming from what we usually call as these ailerons, elevators on the rudder, right? So that's what actually goes with a wing. and a tail, and a horizontal tail or a vertical tail.
Okay.
All right. So you see those planes would actually have these flaps that
Yep.
the pilot would actually be, moving around. Those are the ones that are going through the constant adjustment that you're talking about to stabilize the plane in forward flight. So you don't need the vertical rotors to do this.
Okay.
Right. So at the first level, we can just set them to a constant speed so that they would just do their job of, working with the wing, and you don't need them to actually jiggle in order to be able to adjust the plane. But at the next level, you can actually have a redundant and a second layer of control where, in addition to the aileron, rudder, and the elevator, right, you can also have these as a second authority of control, right, where they do this constant adjustment. And that will consume some power. So the question basically is, what's the trade-off that you want to give for an additional layer of control versus the power it's going to consume?
Like, what work do you have to do with regulators, right? Because if it's going to be in a city, which, as you said, makes the most sense, right? In other words, I don't want to get into a taxi, and definitely don't want to sit in traffic in Jakarta, in Ho Chi Minh,
Yep.
in Bangkok, in Delhi, in Chennai, in Bangladesh. I don't want to sit in traffic, and all these cities have traffic, right? How do you get regulatory approval for that type of flight, right? In other words, even today, regular drones can't just fly wherever they want. How do you solve that business problem too?
Well, this is actually the biggest problem that's staring pretty much a lot of people around the world. So what we have found is FAA in the US and EASA in Europe are primarily seized of this question, and they have been evolving and developing regulatory standards for certification of the aircraft of the kind that we're talking about, the
Right.
VTOL, electric VTOLs. And we basically need to have other certification agencies around the world adopt any of these standards instead of reinventing the wheel, go through these standards to examine the aircraft and certify them based on these standards. That's essentially what we expect should be happening in the next couple of years.
But at some level, it's going to have to happen, right? I mean, if these planes are being built, I don't even know if you can call them a plane, but if these vehicles are being built so that individuals can buy them, and I want to talk about that in a second too, right? If it's at a price point of a luxury car, I don't know what that is, 150 grand. I mean, I'm just making a number up off the top of my head, right?
Wow, how did you know that?
I just, because I mean, that's what a typical luxury, that's what my Cayenne cost me.
Right.
Anyway.
Right.
But if that's the case, people are just going to start flying them around, right? In other words, it's going to have to happen. And if you want to alleviate traffic problems, if we're going to have 10 billion people on the planet, like, flying around in an electrical vehicle, it's just going to be more efficient than driving around in a car, I would presume, right? And at some point, they're going to be a little bit bigger, so you can have more people, and that the weight distribution is going to be better as well. But can regular people fly these things?
Oh, well, you have to ask the question, what did people think about driver's licenses before?
Yeah, I'm asking. It's the same thing, right? It's no different. In other words, if I'm riding around on a horse and I see some dude ride by in a internal combustion engine, I'm like, oh my God, I'm just going to die if I ever have to drive that thing.
Exactly. So did the dude have a license to drive, right? So that's a question you have to ask.
Yeah.
So the answer is very simple. Anybody who wants to actually fly any of these things needs to have a pilot's license, right? Pilot's license to fly this particular plane.
Right.
Okay.
Yeah.
So pilot's license has two parts: a basic a flight training. The other one is training to fly a particular type of aircraft.
Exactly.
Okay.
Yeah.
So we need to go through those, and that's what we expect will happen. So progressively, there can be three levels, right? So let's say, for example, you bought one of these planes. You have the headache of having to actually go through a pilot's training for this particular plane at some point, right?
Yep.
That's number one. Second, you could say, well, actually, if I could afford to buy this plane, I might as well actually hire a pilot, right, who's meant for piloting this plane. So that means it's kind of like a chauffeur-driven,
like a driver, yeah.
Car, right?
Yep.
The third is, forget about all these things. Actually, call something like an Uber, right? That'll get you the plane, and there will be a pilot that's meant for flying this, and then you just go through what's called a shared mobility.
So that's the other thing too, is do you build the shared mobility as part of the business model? Do you know what I mean? In other words, Is ePlane going to be the shared mobility part for air service, right? Because then you don't have to hire, but like you can hire out or contract with pilots. In other words, when I get to the airport here, I'd love to go downstairs or go out back and just drop me off at Scumvit Road. It'll take me 7 minutes, right, in a helicopter or in an ePlane. I'd pay for that. And if you're saying it costs 1.5 times, I mean, it's like 600 baht. I would definitely pay that. I'd pay 1,000 baht to fly from my house to the airport and back. Yeah.
Correct. So the quick answer is, if I were greedy, and I'm supposed to be greedy as an entrepreneur, right? So we would like to actually do that because that's where the money is. But it's a question of whether I can actually raise the kind of money that's required from the investors to be able to do this. And there are questions that people would ask when you're too early, saying, "Hey, look, there are these aircraft manufacturers, and then there are these airlines. They are two different things. So why would we don't really see both of them to be the same, and so on." But in this case, if actually both of them are the same, that's when actually we get the money, right?
But also remember this too, right? And when Grab and Uber and Didi and all these ride-hailing companies or mobility sharing companies started, they were like, we're asset light. Airbnb, the same thing. But they also realized then that they could maintain some of the margin themselves, actually, if they owned the cars, right? So they buy all these, at least in Thailand, I'm sure they buy like all these Toyota Camrys, and then they lease them out to people that are drivers that can't afford to buy them. And it's the same thing for Airbnb. They're like, wait a second, we know how housing works. We're going to just start building and buying our own apartments. We'll keep some of that margin too. Like, why just get a commission? Why not get the whole thing? And then we'll build a company that actually goes out and cleans all the apartments, that services them too. Right? There's a whole bunch of stuff. You can build your entire ecosystem around this if you're thinking big enough. Investors should understand this, no?
True. Well, there are a couple of subtle differences there. So all of these things essentially lead to what's called as asset utilization, right? So you want to actually asset utilization.
Go ahead.
So what Uber does is essentially to utilize cars that would otherwise be parked in parking lots.
Sure.
And Airbnb is essentially trying to do let out rooms that otherwise could be remaining vacant
at the beginning.
Right?
Yeah.
Right. So that's what they're trying to do. And then these rooms and these cars actually pre-existed when the markets when they started the business. So their main goal is to actually expand their markets as much as possible, and their investments are primarily for expansion, right? So when they are actually becoming like a unicorn, they are essentially clocking large market share. That's essentially what they're going after. In this case, the key thing that you have to understand is
it doesn't exist yet.
Sorry?
It doesn't exist yet. Sorry, go ahead.
Exactly, because we don't have the planes yet, right? So we have to actually induct those planes out in the market.
Yep.
Right. But the key thing here is so two things. One plane can probably do about 5 to 10 times the number of trips a road taxi can do. So I know because the trips are very short, right? Yep. So you don't get stuck in traffic.
Yep.
Therefore, the asset utilization in the air is actually a lot better with planes. So you don't need as many planes as the number of cars, right, in the first place. Now, the second thing is, fine, I can actually become a unicorn, and I would still not be grabbing a large market because this is aerospace. Unicorn is kind of like a bare minimum that I need to clock, right? It doesn't mean anything.
It really means nothing, but yeah, go ahead.
Yeah, so that's what it is. So the scales basically shift from what it used to be for an Uber or an Airbnb when compared to what this is. But still, the asset utilization happens from each and every single aircraft, because it does like a lot more trips in a day when compared to a taxi.
Yeah, I mean, you're also building into a greenfields industry, right? Because there is no, like, it doesn't exist yet, right? So you're right that the assets aren't already out there, so you can't use the unused ones because you have to build them. Then you have to make that too. But it feels to me like there's a massive vertical integration opportunity here.
Yes,
if it's done right. Have you raised money for this already as well?
Oh, we've raised 2 rounds, and then we are actually going forward raising the next one. So we've raised about $6 million so far.
Awesome. How long have you been working on ePlane?
I've been working. So we incorporated this in February of 2019. So we made the small plane, and then we wanted to raise money for commercializing it, but the regulatory framework did not exist at that time in 2019 for it. And so we decided, let's not wait for the regulations. So we'll actually do what people are actually familiar with, which is a equivalent to a helicopter for taking people, because drones is something that people are not very much used to. We need to have new regulations.
Yep.
So the whole idea was to actually make something that can fly based on the standard operating procedures of existing helicopters, so that you don't need any new routes, right? So we just said, let's actually go ahead and raise money for the ePlane itself, for taking people. But right when we did this is when the pandemic hit. So the economy went into a tailspin, and that took a little while for us to actually recover from. And so we raised about $1,850K by the end of 2020, and so we did the next 5 million by the end of 2021.
Good for you. What's the status today? You said you're now building an almost full scale model, right?
Yeah, so the subscale, so a 3 meter length subscale is in the works right now.
It sounds super exciting to me. When do you think that that's going to be done?
Expecting by the end of next month, September 2022.
How excited are you?
Oh no, keeping fingers crossed, nervous. It's not my.
Manufacturing's hard of anything, isn't it?
It is. It is. It is. Yeah, everything has to fit in.
Yeah,
Right.
it does.
Yeah.
What does it feel like
Yeah.
to build in India for the world? And I'll tell you why I'm asking, because I spoke to somebody a week ago, and one of the things she said to me was, when a similar generation, right? And she said to me, when we graduated from university, the thing to do was just go overseas and get a job in London or get one in the United States and stuff. And now there's this reverse thing happening where people are coming back to India. You came back right away, right?
Yeah.
But this idea of building
I
from
was
India
the
for the
early
rest of the
idiot.
world. Say it again.
I was the early idiot.
The early idiot, I wouldn't say it, but you were definitely early for sure. But how does it feel to build like from India for the world? You know what I mean?
Yeah. So I think it's not really. I mean, it kind of sounds magical, but it's kind of like what you said about the overnight in 10 years kind of thing.
Yep.
So there are a lot of things that are happening today that is forming like a level playing field across the world.
It
Okay.
is, isn't it?
So just give you examples, right? So 3D printing. If we were to actually do 3D printing, I don't have to worry about whether I'm actually getting a super precision machining done or super precision assembly done, and so on. That used to be like the preserve of the West,
Right.
right?
Yep.
So I just print the whole thing, right? With just a command, like the way you would print something on a paper, right? And similarly, electrification. So I don't have to have these fuel tanks and then these fuel pumps and then the plumbing and all of that stuff. I just have to run wires, which is a lot easier, right? So fundamentally, if you know to take a plane, there are many plane companies around the world making small and large planes, right?
Yeah.
But the number of engine companies is actually very, very few.
Right.
So if you were to throw the engine out of the equation, it's possible for us to actually think about making a plane and then put a battery and then run wires and then connect them to motors and the propellers.
Right.
Now, the last bit is things like carbon composite manufacturing has now become more like commonplace. It's more commoditized. So you have people selling you what's called as pre-pregs that you have to actually lay up on molds and then make parts and then you can assemble them and so on. So 10, 15 years back, carbon composites was extremely niche and very difficult to crack, right? Very expensive.
Yeah.
Right. It's no longer the case, right? So I mean, it is more expensive than metal, but we want to actually reduce the weight, and it's now doable, right? So and similarly, things like digital twins, right? So something called digital twins, or essentially to do something digital, right? So simulate the entire aircraft environment, like the flow fields and the structures,
right?
Everything. Is now much more commonplace than what it used to be about 10 years, 15 years back. So things have changed in the last 5 to 10 years that makes it a level playing field across the globe. That's one thing. The second thing, for example, I think the Indian space story is fairly well known, but the Indian aeronautical story is actually less well known around the world. But pretty much all the majors, like whether it's Airbus, Boeing, Pratt & Whitney, or GE, or Rolls-Royce, all of them actually have their R&D divisions in India.
Did not know that.
In fact, India actually has the largest such workforce on engines and airplane anywhere in the world. And this is kind of like the best kept secret.
I didn't know that.
In addition to this, we have the Indian government actually plowing in money on making fighter planes and jet engines and all of that stuff anyway. Right. So all of these things have been happening and if you look at the military side, right? So India is actually the largest importer of military equipment in the world. And we do licensed production of French aircraft, Russian aircraft, American aircraft. So you tell me whatever it is, we actually buy them and then we get licenses to produce them. Right. So all of the manufacturing capability. And in addition, we have more of the recent ones like Tata's actually are doing Boeing components and Lockheed components and all those things in India.
Right. That's not a big surprise. But yeah. So how big is your company right now? How many people?
We are like about 50 plus.
Oh, wow. That's big. And do most of them come from the Chennai area? I mean, you seem very committed to this.
Committed to what?
Chennai, like your hometown.
Oh, no. So we got to do what's good for the company.
Yeah.
Right.
But I
So
mean,
yeah, yeah.
there's an incredible population of super smart, very well educated people there as well, right? It's not just like,
So the thing about Chennai is not exactly Chennai, it's about IIT Madras. So
yeah,
IIT
exactly.
Madras
That was my
actually
point.
has
Yeah.
a very large startup ecosystem, which is all deep tech.
Yep.
And as I said, in my own center, we have all these other companies like the rocket company, the microgas turbine, the waste to fuel, all of those companies, which are all like super deep tech. It's something that's going for us. So it's giving us a lot of credibility.
Yep.
And I think it's important for us to actually work out of a very creditable academic institution so
Sure.
that we can command the respect of people around for getting things like certification or any kind of collaboration that we want, right? So that's the primary purpose of actually positioning ourselves in Chennai.
Yeah.
But we have a very diverse team that's coming from all over India. And they are here primarily to share the vision and the passion of actually making electric VTOLs for urban aerial mobility.
Yeah, it's a great idea. Is there
Yeah.
some similarity, before I let you go, between the gathering of a startup ecosystem around IIT Madras and what's happened in Boston around MIT and in Silicon Valley around Stanford and Berkeley?
Right. So I think the Silicon Valley story is much bigger than the Boston thing that you talk about, right? So
It is
in terms,
now. It wasn't
yeah,
always that way, by the way, but go
I
ahead.
agree, absolutely. And the reason I brought that up is because the mirror here in India is Bangalore. Bangalore is actually India's Silicon Valley, so you will see a lot of that kind of thing happening in Bangalore. So it's very fair for us to actually compare what we're doing here with MIT, except that I think the kind of scale that we're talking about, we're not really seeing that happening in MIT, right? So making rockets, planes, engines, and all of these things, particularly in one place, right? So I haven't seen that happen anywhere else in the world.
Got it. I just wanted to understand what the similarities were and what the differences were. I really appreciate that.
Yeah.
Satya Chakravarthy, a co-founder at ePlane. I'm super interested in this. I really want to hear more once you build the model that you're building now, get it flying, and then come back on and tell us more. Is that cool?
Yeah, we'll be keen on coming back to you.
Thank you very much.
Thanks a lot. Thank you very much.